Sure, definitely. All right. So the floor over to you, Ms. Khadija.
Okay, distinguished participants, before we start this session, it is my great pleasure to introduce the profile of Associate Professor Dr. Lilam Hong. Associate Professor Dr. Lilam Hong was born on 5th May 1981. He obtained his Bachelor of Computer Science from University Putra Malaysia on 2004. Then he achieved her Doctor of Philosophy in Computer Science from the University of Nottingham. Associate Professor Dr. Lilam Hong is currently a director at Data Ecosystem Research and Development Center, and he is also an associate professor in Faculty of Science and Technology, Quest International University, Perak, Malaysia. Her research areas are machine learning, pattern recognition, text classification, data mining, intelligent system, big data analytics, knowledge engineering, cloud computing, Internet of Things, telematics, and e-commerce. He has also a lot of publication in the international journal and prestigious international conference related to his research areas. Currently, he is working on some research project. The latest one is research and development of face comparison program for electronic know your customer process. Associate Professor Dr. Lilam Hong is also in charge as editor or reviewer in some international journal, such as editor of Journal of Advanced in Information Technology, technical editor in Journal of Applied Science, and etc. And today, Dr. Lilam Hong is going to talk about the application of machine learning, especially for smart manufacturing and precision framing. Okay. Distinguished participants, we have two agendas in this session. The first agenda is the main lecture from Dr. Lilam Hong for about 1 hour. Then the second agenda is Q&A for about 30 minutes. We expect participants to actively participate in the Q&A because the Department of Informatics has prepared special gift for the 3 best questioner. And during the session, you might type your question in the chat panel, or if you have enough time, you may also deliver your question directly to Dr. Lilam Hong in the Q&A. Well, ladies and gentlemen, let's start the first agenda in the session. The main lecture presented by Associate Professor Dr. Lilam Hong. The topic of the lecture is machine learning, especially Industry 4.0 for smart manufacturing and precision farming. Without further ado, Dr. Lilam Hong, the stage is yours.
Yeah, thank you, Ms. Khadija. So once again, good morning, ladies and gentlemen. So it is really my pleasure to have a chance to share some of my project experience with you. Okay, so basically, I understand that you all have a great lecture this morning on the technical stuff about natural language processing. So perhaps to make the event more cheerful, a more relaxed one, but still fruitful, okay? So perhaps allow me to share some of my projects with you, okay? So don't take it as a serious lecture, but something like a storytelling from me. I hope you enjoy the session. So before I start, please allow me to share my slides with you. All right, I would like to check whether is everyone seeing my slides?
Yes, it is.
Yes, right. This is the first slide, right? Okay, so actually, as introduced by Ms. Khadija just now, you may notice that from time to time, I've been working on some fundamental research in computer science area, for example, machine learning, data mining, and how to say that if we do not apply all these research finding into a real life application, the impact our research will bring to the world is quite minimal, I would say. It's all scientific. So based on this concept, so slowly I move into I divert some of my research resources into application. All right, and as everybody aware that especially from the industry sector, recently Industry Revolution 4.0, or in short IR4, this is a hot topic. All right, and in fact, in Malaysia here, a lot of our universities, they use this IR4 to be one of their brand, okay, one of their brandings. So they say that they have advanced technologies, they have a lot of collaborators who are working on this IR 4.0. So so to follow the trend, okay, and we would not say, I would not say that we are the how to say the initiator, but at least we are, how to say, we are going to follow the pace, to get up with the trend of this IR 4.0 technology. All right, okay. So today, let me share with you some of my research experience, okay, in smart manufacturing and also precision farming. Okay, so no worry, there will be no hardcore fundamental or theory type of thing here. But if you like to know about the fundamental, of course, you can contact me. Today it's just like storytelling. Okay, all right. So now let's move on. All right. So okay, we are now, okay, in our current world now. Okay, we are in a data technology era. Okay, so previously people keep on saying information technology. Okay, and some of them they call it as IT. Okay, and later they call it, okay, information itself is not enough. We need communication. Then ICT came out. Okay, the word information and communication technology. Okay, and when the, how to say, the area of computer science evolved. Okay, and when we move towards the, how to say, the advancement in computing, we realize that data, okay, is the key. We can have a very powerful processor, okay, and we can also have a lot of facilities and infrastructure, good network, okay, and good processors and all sorts of things. But all in all, it comes back to the raw material for computing, which is the data. All right. So we are now, of course, I would like to coin our current world, okay, of computing, as we are in the era of data technology. Okay. So data technology, okay. Nowadays, we can see a lot of data are generated, okay, almost continuously from various activities, not only from humans, okay, but also by the machines. Okay, human can generate data, of course. We send messages, we type emails, and all these generate data. But bear in mind, machine also do that. Okay, machine also generate data. Okay, so we can see this rapid growth of data generating, all right, since the last 10 or 20 years, especially the past 10 years. Okay, when we have smartphones, we have cloud computing, we have IoT, okay, Internet of Things, and we have advanced network technology, 4G, 5G, okay, and all this has become more popular and more advanced. And here comes the how to say, the accelerating pace of data generation. All right, so just imagine, okay, this is let's see whether you see this type of situation in your life, in your daily life. Okay, to many people, okay, one of the first few things that they will do in the morning after they wake up, okay, of course, when you wake up, you do body stretching, you drink some water, but definitely to many people, one of those things is to grab your handphone and check on it. Am I right? Okay, so people normally will grab the handphone and start checking, or whether somebody send you any messages through Facebook, through WhatsApp. Okay, you check. Okay, and this generate data. Okay, bear with me. Even if you just launch the app, okay, and check the messages, check the messages, right? That generates data. Okay, because the system will capture that the messages has been read by you. Okay, and that is data. Okay, and follow to our next activities, our daily activities. Okay, when we are working for our entertainment, when we exercise, when we spend money for our daily expenditure, when we have food, dining, almost everything we do, okay, in modern world, that generates data. Okay, and even when we sleep. Okay, and I believe that in some of us, in our home, okay, we have a CCTV, the surveillance system, and also the alarm system, right? Okay, even when we are sleeping, those systems are generating data. All right. So this is how much of data generated from our daily life. All right. So, okay, according to a statistic, okay, published by Forbes, okay, early this year, okay, they say that 90% of the data in the world today, okay, was generated over the last 2 years, okay, when we have 4G. When 4G started, okay, data generating has become very fast, okay. Not to mention now we are moving into 5G, okay, with more advanced and more powerful network, then the pace, okay, of data generating will become not even exponentially, much more compared to exponentially, okay? And there is a quote, okay, which some people say that, okay, 10 years ago, they say that there's a new quote to say that data is the new oil or petroleum. Okay, of course, in Malaysia and Indonesia, we know what petroleum is. We know how important petroleum is because one of the major commodity in our country is petroleum. Okay, but they say that data is the new oil. Okay, that means data is one of the most important resources in modern world and also the future. Okay, and that is one of the important determinants for future economy. All right. So and then according to an unofficial statistic which I found on the internet, okay, to date, okay, it is estimated that approximately 2.7 exabyte of digital data is generated per day in the whole world. Okay, if you have no clear idea on what exabyte is, 1 exabyte is actually equals to 1 billion gigabyte. Okay, 1 billion gigabyte. So it's huge. Okay, so that means, okay, in average, approximately 350 megabyte, okay, that is more, right? 350 megabyte of data will be generated per day, okay. 350 megabytes seems to be small, but just imagine that amount of data is generated for every single person on earth per day, okay. So this is huge, okay. And based on that statistic, okay, it says that out of this amount of data, so currently we have 2.7 exabyte per day, all right, generated, and then it accumulate, we have something like, if I'm not mistaken, it's 30 or 40 zettabytes, okay, of data in the whole world, okay, today. But out of all these 30 plus zettabytes, okay, only less than 0.5% of them is analyzed and used. So you can imagine how big the potential is for data mining, and then we can mine the data, we can fully utilize that resources, okay, I mean the data, to power the world. Okay, so and adding to that, we have seen how much data has been generated per day, right? So adding to that, including Malaysia and Indonesia, we are now in the COVID-19 pandemic. Okay, so we have all sort of preventive standard operating procedure, and we say that we are going to live in a new normal. So under this situation, a lot of our daily activities are happening online. Okay, that means more and more data will be generated. Okay, so for example, like now, okay, we are having this sharing via video conferencing. Okay, this definitely generate a lot more of data compared to if we are having the sharing via a face-to-face event. Okay, when we do face-to-face, perhaps they don't generate that much of data. Of course, data will be generated, but will not be that much. But now we are having an online meeting, a lot more data will be generated. Okay, so this is how data generation happening in the world today. Okay, and therefore we must leverage on data to power the future world. Okay, we must use the data to power the future world. Okay, mastering the data and leveraging on them to make our world better is like conquering it. Okay, and nowadays, of course, the world is still conquered by those countries who have good economic, okay, and they have the most oil reserve, petroleum reserve, for example, okay. But this is going to obsolete. Okay, in the future, data will power the economy. Okay, And then if you own data, that means you have the most reserve, okay, and the more, how to put that, you can master the economy, okay, more if you have more data, and that will make you great, okay, in the world. Okay, so with that, okay, the Industrial Revolution 4.0 technology has provided us a great platform, okay, to change our future to a better one. Okay, so okay, this is the key thing about the talk that we are going to see today, the Industrial Revolution. All right, so before we look into Industrial Revolution 4.0, let's look at the history of it. Okay, so from Industrial Revolution 1.0 to 3.0. Okay, so before the first Industrial Revolution, the production of the world was powered by human labor, animals, and natural resources directly. That means human needs to do hard work to get things done. Okay, and they are helped. Okay, they will only help with some simple machineries and mechanical machineries. Okay, but in the 18th century, okay, steam engine was invented. Okay, and therefore the first industrial revolution, or IR 1.0, was introduced. And since that, people use steam power for production. Okay, they don't use human labor and animals and natural resources anymore, because that is very inefficient. All right, so people start to use steam power for production. Okay, but the application area is very limited. Okay, during that time, okay, when steam power is just introduced for production, right? They only use it in manufacturing and transportation. And the transportation here definitely is not car. Okay, definitely it will be ships and locomotives or trains. Okay, so but it is very difficult to get this steam power production to make it popular, because steam engine is very big. Okay, the size is very big and it's very inefficient. All right, therefore from there people start evolving, and they have reached the second industrial revolution in the 19th century, after almost 100 years. Okay, so in 19th century, IR 2.0, electricity has been discovered. Okay, and also other than this electricity, batteries and electric motors has been invented as well. And since then, okay, electric power is used, okay, widely to create mass production with assembly line. All right, so compared to steam powered machineries, electric power machines are smaller, more powerful, lower cost to run, and therefore it can produce higher productivity. All right, but there is some disadvantages for the electric power machines in this era as well, and in that era as well, in 19th century. That is, the machine needs a lot of human labor to control and operate them. Okay, so when the time evolved from second industrial revolution, the people realized that they still need a lot of human labor to operate the machines. Therefore, the third industrial revolution happened in about 1970s, the last century, the 20th century. Okay, so when electronic and basic computing technology were used to automate production, and now you see, okay, we come to the stage of automation. All right, so people start to use electronic and computing technology to automate the operation of production. Okay, so they use programmable memories and computers, right, to maximize the efficiency of electric power machines, and therefore the output and also the production has been increased, and the process is more automated. In other words, it needs less human labor. All right, and now, okay, from Industrial Revolution 3.0 in 1970s, when it moved to the millennium, okay, in year 2000, and then in year 2011, the fourth industrial revolution was introduced, and we coined it as IR 4.0. So in the rest of the talk, I will use the term IR 4.0, okay, to represent the fourth industrial revolution. Okay, so that was started in 2011. Okay, and it has become popular in recent years. I think about since 2015. In Southeast Asia here, we have commonly seen this term, okay, introduced in, especially in the industry, in the manufacturing industry. So IR 4.0, everybody is talking about IR 4.0 here and there, as you may notice. So IR 4.0, of course, is the extension of IR 3.0, and it leverage on advanced computing processing power. Okay, nowadays we have very powerful processor, and we have very fast internet. Okay, they have also advanced electronics and other digital technologies. So we apply all those technologies to support or to facilitate IR 4.0. So the main objective of IR 4.0, okay, is in contrast to IR 3.0. IR 3.0 is basically to create automated system for production. But for IR 4.0, the aim is to create not automated but autonomous system. You may go and check what's the difference between automated and autonomous. They are two different things. Some of the people, they might think that these two terms are the same. Automated, okay, for IR 3.0, but for IR 4.0 is autonomous. Okay, later I will explain. Okay, later when you go through the entire lecture, you may understand what autonomous is. Okay, so autonomous system will make the production, okay, highly efficient and very convenient to use. That means it only requires minimal amount of human effort. All right. Okay, so let's cover the very brief history about the industrial revolution from 1.0 to 3.0. Okay, now let's focus onto the latest industrial revolution, which is the IR 4.0. So IR 4.0, like the how to say that, like IR 1.0 to IR 3.0, it was originally introduced to the manufacturing and production sector. Okay, IR 4.0 is not introduced for education. Of course, all the industrial revolutions, right? They are not originally, the main area that they are focused into is for manufacturing and production sector. Okay, the goal of IR 4.0 is to computerize and digitize the process in manufacturing. But when it evolved and developed since the past 10 years, it has penetrated into our daily life. Nowadays, we can see IR 4.0 technology almost everywhere in our life. Okay, and that changed the way we live. Okay, changed the way we work and changed the way we communicate. If you, I think we, at least I'm old enough to realize that since the past 10 years, the way we live, the way we work, the way we communicate has changed a lot compared to when we moved from 1980s to 1990s to the millennium, early millennium. Okay, we can't see a very drastic change from 1980s to year 2000. But after year 2000, especially from 2010 to 2010 and to 2020, this year, we have seen a very drastic change in life and our working environment and a lot of things. Okay, so that's how latest or digital technology change our life. Okay, so nowadays we can see IR 4.0 technologies not only in the industry but also in a lot of aspects in our daily life, from our home appliances, our electronics appliances, for example, our television, our refrigerator, our aircon. So those, the modern one, of course, they have some IR 4.0 technologies in it. Okay, and then we can move to office automation, transportation, communications, finance, leisure, entertainment, sport, healthcare, safety and security, a lot of aspects in our daily life. Okay, and we can see IR 4.0 technologies. And in fact, certain people say that actually it is not, we use IR 4.0 technology and make our daily life better. Okay, and actually that is the opposite. Some say that IR 4.0 is actually using our daily life technologies and leverage them onto the industry. So there is a debate going on, but nevertheless, ultimately everybody just want to make our life and our world to a better one. All right. So Now, let's see that how IR 4.0 application is applied into the industry sectors. Okay, and we can find IR 4.0 in different industry sectors. For example, in agriculture, in transportation, security, building management, energy management, healthcare, etc. So all these sectors somehow they use IR 4.0 technology to make the process and operation more effective and efficient. And even so, okay, even so, we can see a lot of the sectors they are implementing IR 4.0 technologies, right? There are still a lot of vacuum areas in this sector, okay, especially in developing countries like us, and not to mention underdeveloped countries, okay, and therefore there is a lot of chance, okay, for us to see how we can improve the the industry sector by using latest technology. Okay, so we apply IR 4.0 technology into the industry. All this come with one common goal. I always want to emphasize that this is not for just not for the sake the the implementation of this technology definitely is not for the sake of we want to comply and we want to show that we are advanced. And not only that, the common goal is to increase the efficiency and productivity. Okay, so that is how IR 4.0 to penetrate into this industry sector. Okay, before that, okay, I nearly forgot to introduce you about the technologies in this IR 4.0 framework. Okay, so IR 4.0 framework consists of 9 main technologies, and we also name that as the 9 pillars of IR 4.0. So these 9 pillars, if you can look at the diagram, okay, on the right hand side of the slide. So these 9 pillars are autonomous system or robotics, cybersecurity, big data analytics, augmented reality or more commonly known as AR, okay, cloud computing, additive manufacturing or 3D printing, simulation, Internet of Things, and system integration. All right, so this is the framework of IR 4.0. All right, so to have a more detailed view into these 9 digital technologies of IR 4.0, right? And since IR 4.0 was originated for the manufacturing sector, so we are now going to look into how these 9 digital technologies could facilitate and bring benefits to the manufacturing. Okay, and now let's look into smart manufacturing. Okay, so before we look into smart manufacturing, let us see now why do we need these 9 pillars in the manufacturing industry. Okay, and today we can see there are a lot of problems that has been facing by the manufacturing industry. Okay, number 1 is the regulatory compliance and traceability. Okay, regulations to manufacturing industry has been tightening from time to time. Okay, in order to achieve high product safety, high workplace safety, and also environmental friendly. So we cannot let the businessmen, okay, to run their factory as they wish. Okay, we need some regulations to guide them, to control them, so that everybody gains from it, and things are done in a proper manner. Okay, so we impose regulations to the industry, to the manufacturing especially, but it is very difficult to use manual ways to trace the regulatory compliance. Okay, because the regulations has been keep updated. Okay, and it has become tighter. That means very difficult to meet all those compliance. Okay, things are getting better, so we need a tight control. Okay, tighter and tighter control from time to time. Okay, and so this has made a problem, okay, to the manufacturing to fulfill the regulatory compliance and also the traceability. Okay, that is number 1. Okay, so number 2 is the manual labor intensive operation. We need a lot of human, or we need a lot of people to work in our manufacturing industry. Okay, in most countries, especially the developing ones, Of course, that includes Malaysia and Indonesia. So our manufacturers still adopting the so-called IR 2.5 technology. Okay, so now people start talking about IR 4.0. But why we are still, I still say that our countries still adopting IR 2.5 technology. Okay, and of course today we don't use steam powered machinery like what we have in IR 1.0, and all the machines are electric powered. That means IR 2.0. Okay, we are implementing that, okay, in our manufacturing sector. However, okay, if you have visited some of most of our factories, okay, some of our factories in our countries, right, we can see that only some of the operations are computerized and automated, and many of the operations still require big amount of human labor. That's why I say that our country is still in the era of IR 2.5. Not many of the operations are automated, not to mention autonomous, okay? Not even automated most of the processes, and therefore we still need a lot of human labor to run the factory, okay? Okay, so this is a problem. So we are still in IR 2.5, okay? And this has brought to a lot of issues, okay? When we need a lot of human to work in our factory, we can see a lot of problems. For example, workplace safety, okay? We need to take care of the safety of the workers, okay? And high operational costs. We need to pay salary. We need to provide hostel. We need to provide meals to the workers, okay? Of course, high operational cost doesn't mean that the cost is very high in the beginning. Okay, the beginning investment, of course, it will be lower because you just need all the basic machineries. Okay, you don't need the advanced one. But in long run, when you need intensive human labor, the operational cost will be high. Okay, if we stretch out, okay, and we take the long term operation cost into consideration. Okay, and to adding to that, of course, the operation in our manufacturing industry is very human intensive, and we need a lot of manpower. But the thing is, the supply is in short. Nowadays, many factories they are suffering in getting workers to work in their plant floor. Okay, especially now, you see we have lockdowns in most of the countries. So foreign workers, they cannot come into our countries and work for the factory. So human labor is now a great problem. Okay, the supply of human labor is now a great problem in most of the industry. Okay, especially in manufacturing. All right. So all these problems will decrease the quality and productivity of the manufacturing process. Okay, and not only that, when we need a lot of human labor to work in our manufacturing environment, that will increase the risk of workplace hazard. Okay, so human being, like we know, we have biological characteristics. For example, we can get reckless. Okay, we unable to handle high stress, and we can get tired easily. So all this will make human labor relatively fragile compared to machines. Okay, and with all these biological characteristics, it is quite dangerous when we put human to work together with the machine. Okay, because machine will not have conscious mind. They will just operate as how you program it. Okay, and sometimes if the human is reckless, okay, that means it's not paying attention to the operation and get tired. So when the human get out focus of what he is currently doing, so when we work with the machine, it will get hurt easily. Okay, so that is a problem of intensive human labor in our current manufacturing environment. Okay, then number 3, okay, is the problem of malfunction machinery. Okay, so the machine doesn't operate in the most optimal way. All right, so this is because inoperate or delay in maintenance. Okay, some of the factory stakeholders, they, in order to cut costs, sometimes they delay their maintenance to the machineries. And of course, if they get the wrong maintenance crew or vendors to take care of their machines. So the maintenance could be inappropriate as well, and therefore some of the machines are not operating under the good condition, and somehow certain parts of the machine has some problems, and that malfunction machinery will not only degrade the quality and quantity of the production, but they will also endanger the operators. Okay, so that is problem number 3. Okay, and the last one, okay, last but not least, this is very serious. This is the last one, but not the least one. Okay, this is very important, is the pollution. Okay, so in all around the world, okay, even in developed countries, okay, factories has been reported as one of the key factors for environmental pollution. Okay, this is because of the operational condition of the factory, especially the waste disposal, are not monitored and controlled well. Okay, because you see, when we can see there are some factories that keep on disposing the waste gas, okay, and wastewater directly to the environment untreated. Okay, so that pollutes the environment. All right, so this is due to the limitation of ineffective infrastructure and loose regulatories and enforcement, and also unethical and irresponsible operators. Okay, so these pollution are not only endangering the environment, but it will affect the entire ecosystem of life. Okay, including human beings. Okay, which will bring a terrible negative impact to the future of mankind. All right, you see, now we have been spending a lot of time on this particular slide. Okay, the challenges in manufacturing. Okay, that means these problems are very serious. So to ease all these problems or even solve them, okay, while manufacturing companies are making the best profit from their business, they also need to be responsible to the ecosystem of life and also the nature. Okay, so they have to follow strictly the legislation, okay, and make necessary changes to the operation to improve them, and therefore they can be responsible to the workers, to the suppliers, to the customer, and also to the environment, to make sure the best interest for all parties. All right, so in view of that, IR 4.0 is able to solve that. Okay, and even though it cannot solve that completely, but at least help the manufacturer to relieve from most of these challenges. And of course, the ultimate goal is still we want to use IR 4.0 to solve all these problems that are currently facing in our manufacturing sector. Okay, so after seeing the problems, okay, now let's look at the first technology of IR 4.0 framework, which is the Internet of Things. All right, so Internet of Things refers to networking and connectivity of smart devices. Okay, when we talk about IoT, okay, Internet of Things, normally the thing immediately come to our mind will be the smartphone, the tablet, the laptop. Okay, but this is not all of them. Okay, IoT covers a lot of areas. For example, we have wearable gadgets, car, home appliances, or any smart machine or smart devices that can be connected to the internet and allows data transmission. All these are IoT. Okay, and there are thousands and millions of items in the world which can be modified and designed, converted to transmit data. For example, okay, now of course there are still a lot of space for us to improve, for us to improve the world. Okay, so in the future, maybe I don't know, maybe even a pen, okay, a suitcase, a shirt, a toothbrush, everything, okay, not only the non-living thing, even living thing like our pets, the animals, the plants, okay, we can somehow make it to get connected to the internet and start transmitting data, and that they are in the IoT community already. Okay, so that is IoT. So in the context of manufacturing, okay, this technology is always referred as the term of IIoT, which is Industrial Internet of Things. All right, so manufacturers are attaching sensors to the machine, okay, and of course other physical assets in the factory to generate and collect data. Okay, so this data will then be used to make real-time decisions, okay, which will make their business and operation more efficient and productive. And of course, collecting data itself will not lead to automatic decision making. You need to process the data. Okay, so after we have collected the data from the machine and asset, so we will send the data to a gateway, and then from the gateway we send to the server, okay, and we store the data in the server and process it. Okay, so after the data is processed, the result will be kept, and also the result can be sent back to the production floor for necessary actions. And for example, okay, to have predictive maintenance to prevent the machine from serious malfunctioning, okay, then we receive the process data, sent back to the production floor. So we sense that there are some minor symptoms which are going to lead to a serious malfunction of the machine. So before the malfunctioning happens, so we can take immediate action to prevent that. Okay, so that can reduce production downtime and also operational hazard, make it safe, okay, and make it keep working. It won't, how to say, it won't stop the production, okay. All right, so the data, apart from get the data to be analyzed so that we get the result and take necessary action, the data can be visualized in the dashboard as well. All right, and then the maintenance crew, the management could take efforts to make necessary action, okay, to repair the machine, and we can also send the resulting data or the action directly to the actuators to make autonomous maintenance and fine-tune the machine up to a certain level. Of course, we can't rely on the actuators to do the full maintenance to our machine without any human intervention, but at least up to a certain level. That makes the life of the manufacturing crew much easier, okay, and more effective. All right, so that is all about IoT. Okay, I hope is sufficient about the introduction of each of these. Also, later on we are going to see more about all these technologies. So we move to the next one, which is 3D printing. Okay, or we call it additive manufacturing. Okay, so 3D printing is also very important to manufacturing industry. Okay, so it was invented back in 1980s and has become popular in the past 10 years because in the since 10 years back, the production and running cost of 3D printing has become very affordable. We can even have a small scale 3D printers at home, just with maybe few $100 maybe. Then we can have a 3D printer. Okay, so this technology is commonly known as 3D printing, but to the industry, the term used is additive manufacturing. All right, so it is also known as additive layer manufacturing, okay, ALM. So when people talk about additive manufacturing or the additive layer manufacturing, we know that that is 3D printing. Okay, so 3D printing use computer aided design, or in short CAD, okay, CAD, and computer control mechanism with solid materials such as plastic to create 3D objects. Okay, some of the industry grade 3D printers can even print objects by using materials such as rubber, metals, and even ceramic, okay, which are very useful to create tools and parts for machineries. Okay, so how can 3D printing bring benefit to manufacturing? Okay, so we are going to look into some of them. Oh, sorry. Okay, here. We are going to look into some of them. Okay, so the first one is for design and prototyping. Okay, so by using 3D printing, okay, which is flexible, okay, 3D printing actually is very flexible. We can create any object that we want. Okay, so the design team can do experiments by creating objects with complex shape and structure. So you just need to design it. Okay, they can use computer aided design to develop any shape of any size of the object and print it out using 3D printer. Okay, so the self-designed object can then be used to develop prototypes at a much lower cost. Okay, they can design and build any parts or any tools as they wish. Okay, and use that for prototyping, and they don't need to purchase those parts and tools from the vendors. And this can save time as well, because if you want to order those parts and tools from the vendor, okay, if you only need a very small amount, small volume, then the cost will be high, and the process, okay, the procedure, the procurement procedure, and then the delivery procedure, okay, everything that takes time. So if you really need a small amount of parts, then you can use 3D printer to create that. Okay, so in view of that, another usage of 3D printing in manufacturing is for low volume production. Okay, so when we only need a small amount of product, then 3D printing is the fastest and the most economical way to get the materials or parts that we need. Okay, so that is about 3D printing or additive manufacturing. Okay, so now let's move to the next one, which is autonomous system. Okay, or most of the people know it as robotic. Okay, robotic, of course, it is used in manufacturing since maybe back in 1980s or 1990s. Okay, so people have started using robots in manufacturing. Okay, so in today's manufacturing industry, we can see a lot of robots have been used in the factory for automation. Okay, IR 3.0 automation. All right, so however, there is still a big gap to address on these old-fashioned or conventional robots. Okay, in order to create an a good environment which human and machine can work together in a more interactive manner. Okay, previously we have seen that in the factory, we have a lot of people working there with the robot, and it is quite dangerous to the people because robot has no conscious mind, because robot will only operate as according to the instruction and commands. Okay, so now we have automated that process, and now we want to make it autonomous so that human and machine can work together in an interactive way. Therefore, we introduce an advanced type of robot, which is known as collaborative robot, or in short, we know it as cobot. Okay, it's not more robot, but cobot, C-O-B-O-T. Okay, we introduce that to the production line. Okay, so that can bring manufacturing automation to the next level, which is autonomous. So these cobots are designed to work in a way which is similar to human, and it is much more robust, okay, much more communicative, so they can work together with humans in a more effective and efficient manner. Okay, so this robot will have the ability to monitor and communicate, not only with humans, but also with other robot or machines. And ultimately, we are not just looking at the automated process in manufacturing, but we want to achieve autonomous operation, which means the machines are self-governing. Okay, don't need many commands to operate, and have the ability to learn and adapt to instant changes, which can make decisions to do their job on their own. That is ultimately we would like to see that in our factory. Okay, by using cobot. Okay, all right. So okay, all right. So far we have seen 3 pillars of IR 4.0 technologies. Okay, and their implementation in manufacturing industry, and so far these 3 pillars, right, they are more on the hardware side. Okay, so in modern, now let's look at system integration. Okay, so in modern factories, we have a lot of systems which help the operation of the factory. For example, we have manufacturing execution system, we have enterprise resource planning system, we have logistic and fleet management system, and each of all these systems, they are connected to each other up to a certain extent. Okay, so the way that they get connected is mainly among the system software for data and information sharing, which is not good enough for production efficiency. Okay, so many manufacturing information systems are currently not fully integrated. Okay, due to the limitation of networking infrastructure. Okay, so nowadays we have 4G and 5G is coming is coming soon. So with the advanced network infrastructure, we can have connectivity among all the among more and more components in the factory. For example, IoT, the gateways, the server. So all these components, we can make the system integration and connectivity in a much wider scope. So the connectivity is not just between software and human, okay, but can be extended to software and machine, machine and machine, okay, machine and the operators, machine and the management, machine and the maintenance crew, and even get connected to external parties, okay, to other factories, to vendors, to client, to designer, to sales team, to procurement team, to logistic team, and basically, okay, all the stakeholders and parties in the entire ecosystem of the industry. Okay. All right. So with this system integration, we can greatly optimize our business operation. So with better system integration, companies can become more interconnected, both externally and internally. Okay, and this will bring to an agile and manufacturing environment, which allows real-time production correction and also execute contingency plan. Okay, so now we have seen system integration. So system integration basically is sits on the infrastructure and networking infrastructure and facilities, right? And that leads to cloud computing. Okay, so in order to achieve system integration at a bigger scale and wider scope, okay, with the advanced network infrastructure and also computing technology, data storing and processing in manufacturing can be improved as well. Okay, and this is addressed by cloud computing. So many cloud computing providers such as Google, Amazon, Microsoft, Alibaba, and of course many more, okay, offer scalable and high capacity storage and configurable processing power at a much lower cost compared to having a local server. Okay, so the cloud, okay, also improve data accessibility and integrity to promote data sharing, and this is very important for our future. Okay, data integrity, data accessibility, okay, that become data sharing. When we have data sharing, that means when we refer back to the beginning of the talk, data sharing is very important because data is going to be the new resource of the world, and we can use it, okay, leverage on it to power the future world. Okay, so that is how important data is. Okay, and with cloud computing, it has provided us a great platform in order for us to move into that direction. All right. Okay, until now, we have seen the IR 4.0 technologies, which are hardware and infrastructure oriented. So we have seen IoT, we have seen robotics, we have seen 3D printing. So these are very hardware oriented. Okay, and we have also seen system integration and cloud computing. So system integration and cloud computing, it is about networking. So for networking, we need the network infrastructure. Okay, so these are all hardware and infrastructure oriented, and from now on, we are going to see the software oriented technologies. Okay, so let's start with the simulation. Okay, so nowadays, we have advanced computing technology. For example, we have high processing processor, and then we have big data. Okay, so with all this, we can create simulators for manufacturing process. Okay, and this the simulation, right, is to reflect the physical world production process in a virtual environment using real-time data. Okay, so we can use simulator to run the test virtually so that the setting, the configuration can be optimized and well planned in a more effective way. Okay, so we run simulation on real time, in a virtual environment, and we can avoid to perform the test on the real production floor and the real machine. Okay, but yet, even though the test is run virtually, but it still can reflect the actual behavior of the system. Okay, so by having the test on a virtual environment, of course, we can reduce the risk of misconfiguration and also wrong setting. And then we can reduce the cost as well because we don't need to run the test on a real machine, and we need to stop the production in the factory for the test. We don't need to do that. Okay, all this can be done in a simulator. Okay, and that will reduce the downtime of the manufacturing process and maximize the production. Okay, so that is for simulation. Okay, so the next technology that we're going to look into is the augmented reality, or in short, AR. So AR is a technology which displays the real-world object and also the digital content and information in the same device. For example, a mobile phone or smart glasses. All right. So of course, to a consumer at a consumer level, we have experienced AR in a more entertainment type of environment experience. For example, we play games. Okay, nowadays we have a lot of games which are developed by this augmented reality technology. Okay, but this technology is applicable and it has various applications in the manufacturing industry as well. So, for example, number one, to train the new staff, provide training to the new staff. Okay, so whenever factory has new recruits, right, the factory needs to get the new staff to familiarize with the factory environment, regulation and protocols, equipment and facilities, and the procedure on the production floor. Okay, so by using AR technology, right, training can be done in a more effective and interactive way. Okay, that means the trainee can receive information such as text, audio, and images, overlay the real-world objects and other digital content. Okay, so this can help them understand about the machineries and the production floor better without needing additional resources. For example, we don't need to bring them to the production floor and stop the production so that we can train them, and we do not need dummy machines. Okay, we do not need dummy machines for training, so we don't need all these things. So everything can be done by using AR, and yet it is still effective and efficient. So use AR for training is number one. Secondly, we can streamline our logistic process. So inventory controls and warehouse management, these need a lot of manual effort, okay, to check on the items for purchases and for sales, for shipment. All right, and if we use manual efforts to do all this checking, we know humans sometimes we create errors, okay, compared to machines. Okay, sometimes humans will make mistakes in identifying the wrong items with the wrong quantity. Okay, by using AR, the inventory process can be controlled and automated to reduce the error and save time, save money, and save resources. Okay, and that is number two. Number three, for maintenance. Okay, so we want to see how AR helps in the maintenance in manufacturing. So with AR, maintenance crew can save time and reduce mistakes while doing troubleshooting. Okay, so AR device can provide information about the equipment, for example, the maintenance schedule, okay, the potential issue of the machine, and also the service history of the machine in an overlay image of the real object and also the digital content. Okay, so it makes troubleshooting more accurate. So with the help of machine learning and data mining, okay, AR can even suggest the steps and the tools and also the parts for the maintenance job. So to make it more effective. And so everything, okay, all the technology that we use, okay, in manufacturing is to make the thing better, to make it more effective and more efficient. Okay, so that is how three possible applications that AR can be implemented in manufacturing: for training, for logistics, and also for maintenance. Of course, based on our imagination, we can create more and more applications to this, okay, to the manufacturing by using AR. Okay, but so far these three are the most common ones. Okay, and they have materialized it. Okay. All right. So now let's move to, if not mistaken, this is the second last technology that we're going to see in IR 4.0 in manufacturing. Okay, so cybersecurity. Okay, so apart from all those networking, simulation, hardwares, and infrastructure that we're going to see, so all these create data transmission, and therefore cybersecurity is very important and very crucial in implementing these technologies in manufacturing. Okay, because a lot of components in the manufacturing industry, they are connected, and data is transmitting, okay, from different components to another one, okay, in the entire business process. All right, and therefore the risk of potential cyber attack increase along the side with it. And we have to look into the way to protect our system and also our data. Okay, and then this is like if you have many people coming in and out of at your premise, okay, you need a guard house or a checkpoint at the entrance for security purposes. Okay, and the same concept, okay, if we have data coming in and out from our system, okay, and we have network, we open the access to external party, not to say to the public, but to a certain external parties, right? We need to protect our system as well. Okay, so network intrusion or so-called the hacking, network hacking could damage the entire business activities and ecosystem. Okay, which networking is one of the major components. So when we have networking, people can intrude. Okay, and that intrusion could damage the entire business and entire operation. And therefore, we really need to take good care of it and safeguard it. And it is very critical for companies to prepare and protect their cyber physical system and production line from cyber attack. And therefore, technologies such as firewalls, okay, can be used to address these issues, okay, protect our system. Okay, therefore, cybersecurity is something that we really need to look into as well. Okay, okay, okay. The last technology that we're going to see in manufacturing. So, after seeing all this, okay, after seeing all the technologies to make manufacturing smarter, easier to operate, and highly productive, okay, and we can see that there is one common activities among all these technologies, which is data collection, transmission, and processing. It comes back to data. So we have IoT, we have robotic, we have simulation, we have 3D printing, all this, okay, they have one common activities, which is they generate data, they collect data, they transmit data, and they process data. Okay, so when we have this phenomenon across all these technologies, right, that leads to one common goal, which is to discover knowledge, okay, or so-called the knowledge discovery to help in making the entire business operation more effective and efficient. All right, so we have the data and we need to extract the knowledge out of this data, and this data normally they will be unstructured. Okay, so what we need is, and the most important one among all these 9 technologies is the big data analytics. Okay, at least to myself, this is the most important one. Okay, because I think you should guess why I say this is the most important, because this is my area of study. All right. Okay, so of course, with all this data, right, we can discover a lot of knowledge from it. Okay, and in the manufacturing industry, we are just at the beginning stage to scratch on the surface. Okay, we do not deal much with the data. Previously, I have mentioned in the whole world we have a vast amount of data, and we have only used and analyzed less than 0.5% of it. Okay, and that is even lesser in the manufacturing industry. Okay, and there are some issues with the manufacturing industry which I will explain to you later. Okay, therefore, okay, computing technologies such as data warehousing, data mining, machine learning, these are very important to drive IR 4.0 to a success. Okay, and even to push the world into the next industrial revolution. That means big data analytics is very important to move IR 4.0 to IR 5.0. Okay, but collecting data from manufacturing sector is a great challenge, very difficult. Okay, because many companies see their data as highly confidential, and of course they see data as their asset, okay, very valuable asset, and they do not have the confidence on the existing technology and infrastructure and even their vendors. And therefore, as a computer scientist, like I believe everybody here, as a computer scientist, there are great potentials and opportunities for us to develop some major and reliable technologies in both the fundamental and applied areas to facilitate the activities in our world. Okay, all right. So now I hope the introduction of all these technologies will not make you all get bored. So is it okay if we have a short break, or you want me to continue?
Okay. Maybe you could continue to.
Sure. Okay, if you want me to continue, then it's okay. Okay, because it has been quite some time since I first start talking, so perhaps I would like to see whether everybody is okay with it. All right. So if that's the case, let's continue. So I hope after the introduction on all these nine technologies in IR 4.0 framework, and also their application in manufacturing industry, you will have a clearer picture on what are what are these technologies and how they can be used to make our world a better one. So with that, okay, now as I promised you that this is going to be a storytelling and experience sharing session, right? So let me share with you one of our smart manufacturing projects in a semiconductor manufacturing plant. Okay, so we have one project, and this project is still at a very early stage of implementation of IR 4.0 in manufacturing. So we are currently at the phase of getting data to monitor the operating condition of 40 machines in a factory. Okay, so we install various sensors to collect information such as the vibration, the noise, and the working temperature from various parts of the machine. Okay, in order to monitor the health condition of the machine. So besides this, okay, apart from sensors, we have also captured the image of the console LCD display. Okay, so we fix a camera on top of the LCD display of the machine, and we use OCR, or optical character recognition techniques, to extract the data from the machine. Okay, so after that, we send all this data to a server for storing. Okay, and we have some simple reasoning process to analyze the data, and then we have a dashboard to visualize the data and the result. Okay, so this is our project, and as I mentioned, this project is at a very primitive stage because what we can do is only to monitor the health and condition of the machine. And why we only monitor the health? Okay, there's a reason. Okay, because the internal policy of the company does not allow us to have full access and to have full access to the data. Okay, so at this stage, the company is hesitate to release their data for further analysis. Okay, because they see the data as their asset and treat them as highly confidential. Okay, so what the company did was they requested us to have a contract with legal binding with them so that we will not disclose the data, even use the data for our own experimental purposes. So therefore, what we can do is just to extract the data from the machine, do some simple reasoning, and display the data and result on a dashboard. Okay, so that's it. But of course, we are finding ways to bring this project to the next stage. We are still talking to the company, and hopefully we can do something more out of this. And however, we see this as a good start, and perhaps we could move to the next stage in the near future. Okay, so this is how we implement IR 4.0 to make the manufacturing smarter. Okay, and this is one of our projects. And I hope this sharing could brainstorm you guys, and then later when we come to the Q&A, you guys can share your opinions and your ideas with me to see how we can bring this to the next level. All right. Okay. So if you can see from this slide here, the company doesn't even allow us to take photo from their production floor. So you know how how to say, they really want to keep their operation as a how to say, highly confidential. Okay, we can't even take photo from the factory. So not to mention that we can manipulate on the data, we can use the data and for experimental purposes. So that is our problem, and we are trying our very best to overcome it. Okay, so I think that's all I want to share about smart manufacturing. Okay, and as I promised you guys since the beginning of this talk, apart from smart manufacturing, I'm also going to share with you my experience in implementing IR 4.0 in agriculture for precision farming. Okay, so from now on, what we are going to look into is IR 4.0 in agriculture. Okay, so if you can see from this slide, okay, this is the GDP, okay, of Malaysia and Indonesia. Okay, I how to say, I retrieved this statistic, okay, from a German statistics portal called Statista. Okay, and it shows that manufacturing and agriculture sectors have contributed to almost 50% of the GDP in both our countries, Malaysia and Indonesia, and that contribution is high. Okay, so if you can see from the graph here, okay, the highest contributions which cover the other 50% in our GDP is from services sector. Okay, the gray color ones, okay, those are services sector. But services sector covers a lot of industry. Okay, education, healthcare, tourism, finance, ICT, and many more. So these are all considered or categorized under services sector. Okay, therefore, the main industries, okay, which contribute to the most to our national income are still manufacturing and agriculture. So we have seen manufacturing, okay, IR 4.0 from in manufacturing. Now we are going to see IR 4.0 in smart farming. Okay, so before we look into the technology, again, definitely there are some problems for us to solve. Okay, what we want to solve with those technologies. Okay, number one, in agriculture, okay, most of the agriculture activities, right, the main idea of them is to produce food. Okay, and we cannot deny that our world now is suffering from food crisis. Okay, so even though this phenomenon is not serious yet, at least in our region, okay, it is not serious yet. We are not in food shortage or even close to that. Okay, because we can still see food wastage is happening everywhere in our region. But this is quite clear that we are moving towards a situation which will have problems in getting good quality food. Okay, and in fact, some parts in the world have been suffering from famine. Okay, for decades and decades. For example, in Africa's countries. Okay, they are really suffering. Okay, food crisis is really serious over there. Okay, so this is something that we really need to look into before the thing gets worse and the problem come to our region. We really need to do something before it happens. So therefore, in our region, we promote agriculture. Okay, so the growth in agro-food production. Okay, even though we promote agriculture, right, the growth in agro-food production is just cannot cope with the growth of human population. Okay, and this phenomenon has become serious. Okay, when the world develops. Okay, if you look at the right hand side of the slide, the graph, so the growth of the agro-food production, just the how to say, the development, okay, or the increment of the agro-food production is lower compared to the growth of human population. Okay, and we have this problem because many agricultural lands has been converted to commercial and industry purposes. Okay, and besides this, climate change, okay, due to global warming and environmental pollution, so natural disaster, So all this brings negative impact to food production. Okay, so this is something that we really need to look into. Okay, and secondly, still come back to pollution. Okay, so talking about pollution again, as this is also one of the problems for manufacturing. So conventional way of farming has also so-called contributed to the environmental pollution. Okay, so in order to make agriculture highly profitable, many farmers have used the land inappropriately for their agriculture activities. Okay, they clear the jungle to plant crops, okay, and cause deforestation. They clear the hill slope to plant crops and cause landslides. Okay, they burn the fields to remove the plants that have been harvested and cause air pollution. And besides this, so excessive use of fertilizer, pesticide, and discharge of untreated waste from the plants and livestock into the source of water, into the air, or onto the land, that cause air and water pollution. So all this comes from the unethical and inappropriate, unethical farmers and inappropriate farming activities. Okay, so it spoil our environment. Okay, and bear in mind, humans need healthy food, clean water, fresh air, and solid land, and balanced natural ecosystem to survive. Okay, so these are basic needs of life. Living creatures, including humans, can live without modern technology. We can live without handphone. We can live without cars. We can live without internet. Yes, we can live. Or not to say live, we can survive. Okay, we won't die. Okay, and as we can see from ancient men, okay, or ancient people, long time back, okay, the ancient people survived with only these basic needs: the food, water, air, land, and balanced ecosystem. Okay, they survive, and not only they survive, they evolve and develop based on all this. And today, we are enjoying all this luxury resulted from the evolution and the development. Okay, but sadly, we forget about the basic needs, which keep us surviving and keep destroying them with our daily activities, our agriculture, our manufacturing, keep destroying the basic needs of life. And therefore, this is very critical that we need to address this issue before it is too late. Okay, so one of the ways, of course, other than changing the way back to the back to the, how to say, the beginning stage, like they behave themselves so that they have everything well controlled. Okay, if that will of course reduce the productivity. Okay, people, the manufacturers and farmers, they destroy the environment because they want better production. Okay, they want better production, but to achieve better production, sometimes you don't need to destroy the environment. You don't need to destroy the nature. We can use technology, okay, to create a more efficient and a more sustainable world, okay, with highly productive of this industry. Okay, so these are the two problems, okay, food crisis and agriculture pollution in farming. Okay, so let's look into this. Okay, the supply chain of agriculture. So IR 4.0 technologies can be implemented into the entire food supply chain, from the production of food or farming, okay, to transportation, to processing, to packaging, distributing, sales, and even food preparation or cooking, and even dining. Okay, so at least one IR 4.0 technology somehow play a role in these processes. Okay, so today we are not going to look into the entire food supply chain, but let's focus on farming alone. Okay, so IR 4.0 technologies can help the farmers to maximize agriculture productivity and quality and reduce the operational costs, and therefore it will maximize the farmer profitability. It can also protect the environment by having proper planning, from selecting the land, clearing the field, usage of fertilizer and pesticide, irrigation until harvesting. So we can use technology to facilitate all these process so that they will be highly efficient and yet it will not destroy the nature. Okay, so when the food is undergoing the processing stage, smart manufacturing will come into the picture. Okay, and therefore we have seen smart manufacturing, therefore food processing is more or less the same as smart manufacturing. So today what we are going to look into is farming. Okay, as of now, from now until the end of the talk here. Okay, we are going to focus on the farming only. Okay, not the processing, not the distributing, not even sales and consumer side. Okay, so all right, so how are we going to implement all this IR 4.0 technology to achieve precision farming? Actually, there is no user manual or no rule book to teach us how to implement the technologies in smart farming and also the entire supply chain. It is all based on our creativity and innovation. Okay, so what we need to do is we need to bear with the rule of thumb and the fundamental principle of these technologies. Okay, and apply them wherever is applicable. Okay, to make the farming activities better. Okay, we have to use our creativity to design the right solution to overcome the problems in farming. Okay, so let me share with you again our precision farming project in Malaysia here. So again, we are also in a very primitive stage in implementing IR 4.0 technologies to farming. So what we have done are collecting data from farm using various sensors and cameras and send the data to the cloud server for storing and processing. Okay, so at the moment, okay, we use a simple rule-based engine to do the reasoning, okay, to make decisions for some activities in farming, for example, fertigation. Okay, so the system retrieves soil nutrient composition, okay, and soil moisture level and soil temperature using sensors, and then they send the data to the gateway, and then the gateway send the data to the server. The server, inside the server, we analyze the data in a real-time mode, and we get the result and send the result back to the farm again and trigger the pumps whenever it's necessary, the water pumps, okay, to dispense the right amount of water diluted with the right composition, the water diluted with the right composition of fertilizer to the plant. Okay, so the system also controls the ambient temperature, okay, the humidity and the light condition. Okay, so by sensing this property using sensor and trigger the ventilators, the humidifier, and also the light. Okay, and then what we are doing now, okay, is to collect data, monitor the condition, and maintain the condition to create a suitable environment for the plants to grow. Okay, so this is our current stage, what we are doing now. Okay, and ultimately, we wish to implement cognitive computing to facilitate precision farming. Okay, so we want to use cognitive computing models to simulate the human thought process in a complex situation. We know that farming sometimes is not as straightforward as sensing the soil, sensing the ambience, and then make decisions. Okay, the situation could be very complex. Okay, and the answer or the response that we need for the situation can be ambiguous and uncertain. Okay, and therefore we need artificial intelligence and signal processing technologies. For example, machine learning, knowledge reasoning, natural language processing, and speech recognition, computer vision, human-computer interaction, and many more. All right, so we need all these technologies to achieve our ultimate goal. Okay, and not only the sensors and actuators and reasoning process, we are also looking into something which is beyond Internet of Things. We call that the social web of things. Okay, which is we use dialogue and narrative generating techniques to make the machine and devices, the sensor and actuators, so that they can communicate among themselves for decision making. Okay, and we don't need human intervention. And this is what we are trying to achieve in the future. And of course, by saying that, we are looking for ideas and comments. Okay, and of course, input from all of you here. Okay, and as I mentioned, this is a sharing session. Okay, So now let's look into some details of our smart farming projects with the implementation of IR 4.0 technologies. So as mentioned earlier, we use various sensors to monitor the farm conditions. Okay, we collect soil condition data. Okay, we collect the condition the data from the soil. So one of the sensors that we use is the Mpk sensor. So Mpk stands for nitrogen, N stands for nitrogen, P stands for phosphorus, and K stands for potassium. Okay, so these three nutrients, right, is the main how to say main components of a fertilizer. Okay, so with this sensor, we can monitor the nutrient composition of the soil. Okay, and we also use soil moisture sensor to sense the moisture level and also the temperature of the soil. Okay, so we also use uh, various type of sensors to collect ambient condition data. For example, we use a thermometer, okay, to collect the ambient temperature. We use a moisture sensor or humidity sensor to collect the humidity level of the air, and also we use light sensor to collect the light condition, like the lighting condition of the ambience as well. So we use sensor to collect data, and these data are then sent from the sensor to a gateway, okay, and then sent to the cloud server, and we have a web-based dashboard to visualize this data. Okay, and in the server, we have a decision-making engine to analyze the input data and make necessary action to control the actuators. For example, the pumps to dispense water and fertilizer, okay, to the soil, okay, and we control the lighting equipment as well, okay, to make sure the light condition is in the right order, okay, and we also control the humidifier and also the ventilator to keep the farming condition suitable for plants to grow. Okay, so of course, as I mentioned just now, our target is not just to keep the farming conditions suitable, but we want to make the condition optimum for the plants to grow. So, and not only that, not just the condition, the environment, the condition of the farming environment or the farming atmosphere, we also aim to minimize human labor and the operational cost, and most importantly, we want to maximize the yield. Okay, so these are the technology that we use for our farming project, precision farming project. Okay, okay. So now, storytelling again. Okay, this is our first field trial. Okay, a greenhouse at IR 4.0 Technology Center in Batu Kawan, Penang. So this center is called Alliance I 4.0 Technology Center, and we started the project of precision farming in the end of 2019. Okay, so the greenhouse is now under the care of the technology center. Okay, and it is not for mass production. Okay, this greenhouse in the technology center is not for mass production or even for commercialization. It is just for showcasing and experimenting purposes. So we plant lettuce, we plant chili, we plant bell pepper, ginger, okay, using both soil-based and hydroponic methods. So if you are interested in any IR 4.0 projects, especially in smart farming and precision, smart farming and also smart manufacturing, you can contact this technology center for collaboration. Okay, so this is our first field trial. Okay, our second project in smart farming, okay, is at a Manila Farm in Penanti, Penang. So this project was started in the middle of this year, okay, in collaboration with some investors and farmers. So we use the similar technology as what we have deployed in the technology center, the greenhouse in the technology center, and for showcasing purposes during the launching ceremony, we have also included voice commanding control to activate the actuators. For example, spraying water, okay, uh, turning on and off the light. Okay, so we use voice command. Why we have this module in addition to the technology that we use in the technology center is because we want to maximize the yield. Okay, so Hello. It seems that I was offline just now. So
Yes,
can you hear me?
yes, you.
Yeah. I was offline just now. I noticed that. So may I know where I stopped?
The last slide is on. The last slide is on Fit Trial 2. Fit Trial 2, Manila Farm in Penang, Malaysia.
Which one, the greenhouse or Manila Farm?
Manila Farm in Penang, Malaysia.
Hello. Can you hear me?
Yes, yes, we can.
Manila Farm.
Yeah, Manila Farm.
Okay.
Manila Farm, but
Okay. This Manila Farm. Hi, Miss Khadija. Can you hear me? Shall I continue?
Yes, we can. Yes, we can hear you. But we would like to remember, Dr. Lam Hong, we still have time about 5 to 10 minutes. Okay.
Okay. Sure. No problem. Okay. So okay. Sure. I know how to manage the time. So okay. About the Manila Farm. Okay. So we use the similar technology that we have used in the greenhouse, but with one additional module, which is the voice commanding control on the actuators, so that
Lam Hong, sorry, maybe you try to share screen again because the screen is off. You start
share the screen again. Okay, sure. Just a moment. Okay, can you see my screen now?
We can see the slide. Okay.
You can see the slide, right? Okay. So sorry for the hiccups. Okay. All right. So okay, let's continue on this Manila Farm. Okay. So this Manila Farm is our second implementation of smart farming, and we implemented the similar technology as what we have in the greenhouse in the technology center, and with one additional module, which is the voice commanding control to the actuators, okay, to spray water, to turning on and off the lights, and so on and so forth, because we want to get the platform ready for research for social web of things. Ultimately, we want the server, the device, the sensor, and actuators can communicate among themselves and do their job autonomously. Okay, so this is our third project, okay, an aquaponic farm for smart farming. Okay, so for this farm, aquaponic farm, right, freshwater fish and vegetables are growing under the same greenhouse. Okay, and they help each other to grow. So other than monitoring the condition of the vegetable farming, like what we did for the previous project, we also monitor the water condition of the fish pond. Okay, so we install extra sensors to measure the condition of water, for example, the dissolved oxygen level, dissolved soil solid, and then pH level and temperature of the water. So what we need to do is we need to control the water condition in the fish pond so that it is suitable for the fish to live in. And we also need to control the condition of the nutrient of the water from the fish pond to the fertigation system so that the water is suitable for the plants to grow. And after that, we also need to control the water conditions from the hydroponic system back to the fish pond so that it is safe to the fish. Okay, so after seeing these three projects, you may notice that our field trials are very primitive. Yeah, I admit that it is very primitive with simple monitoring, reasoning, and controlling mechanism. Okay, this is because at the beginning stage, we are lack of data for advanced analytics and inference procedure. And of course, we are also lack of resources and platform to deploy more advanced technology. But this is not going to stop us from making our system smarter. Okay, and in fact, we have some technology which are currently under developing and testing. Okay, so one of them is this, the computer vision and machine learning for food ripeness grading. Okay, so we are currently working on this system, okay, to check on the food on the plant from time to time, okay, whether they are growing well at different stages. Okay, when the growing environment is under the control conditions by the sensor and actuators, we want to see how the plant grows. Okay, so this will help us in determining the effectiveness of our first stage implementation of smart farming. Okay, whether the control can effectively improve the growth and productivity of the crops. And this will help us in improving our system. Okay, from making the condition suitable to making the condition optimal for farming. Okay, so using the same technology, okay, we are also developing the system and testing. Now we are already at the testing stage to detect pest and plant disease. Okay, again with the 24/7 monitoring. Okay, this can help us to have a better control for a healthy growth of the plant. Okay, and take necessary action at a very early stage to minimize the harm by the pests and the disease to the plant. Okay, we want to keep the plants healthy, so we use this technology to monitor the plant. Okay, so apart from the farmer community market segment, so we also target the agro-food distributor and consumer. Okay, so for the distributor, we have developed a system which can detect the species of durian using computer vision and machine learning to help them categorize the food more effectively and accurately. So using the same AI model, we have also developed a mobile app, okay, for consumer market. Okay, so most of the consumer, they are unable to identify the types of durian accurately. Okay, and different durian will have a different price tag. So okay, different durian will have different price tag, and therefore with this system, the agro-food manufacturer, the distributor, and consumer can enjoy the benefits of IR 4.0 technology. Okay, I think due to the lack of time, let us quickly move to the end of the talk, and then because I've shared most of my projects with you, and then the rest of the slides, they are just the same technology in manufacturing or in IR 4.0 framework. We apply them into agriculture, so it is up to our imagination and creativity to see how we can apply those to solve agriculture problems. Okay. Okay, now the second last slide for my talk. Okay, so this is the thing. Okay, so as you may notice that some of the IR 4.0 technologies take AI and machine learning as the core components. Okay, for example, simulators need to learn from historical data and knowledge to provide simulation and prediction. All right, and collaborative robots or cobots need to learn how to carry out their tasks autonomously and how to interact with human and other machines. Okay, gateways and firewalls need to learn the data transmission behavior and also the patterns for potential intrusion. Okay, big data, no doubt. Okay, machine learning is the core of big data. Okay, so no matter how important machine learning is in this technology, it is still back to data. Okay, so without data, all this goes to zero. Okay, even machine learning can give us very useful model to serve as a core of many systems in smart manufacturing and smart farming. But bear in mind, AI is not magic, and machine learning is not a magic. All right, so we always have to bear in mind one concept of computer science, which is garbage in, garbage out. So AI will not do wonders. Most of the laymen think that it can do wonders, but it will not. If we do not understand the principle and fulfill the fundamental needs of it, which is we need high quality data and the right model, AI won't work. Okay, we need high quality data and the right model for AI to work. Okay, if we have low quality data, even though we have choose the right model, the result could be terrible. Okay, similarly, if we have the high quality data, but we choose the wrong model for the system, the output could be not helpful as well. Okay, so there's the end, of my talk. So I understand that many of the audience today, we have background in machine learning, right? So in that case, in the context of data mining and machine learning, I have two suggestions for research direction in relation to IR 4.0. So number one, we need to understand the data. Okay, machine learning techniques and the application, and we need also to get the right combination of these components. Okay, we need to get the right data and the right technique in order to guarantee high quality or at least a satisfiable level machine learning models for our applications. Okay, so we need to understand the data and also the model. Okay, secondly, due to the fact that good quality data is very limited and very precious, and worse still, some parties treat them as highly confidential, and we always do not have enough data to build the right machine learning model for our application. So this is very crucial, okay, especially to the mission critical system. Okay, mission critical system cannot afford failures. Okay, cannot afford for failure. Therefore, we really need to understand the fundamental of AI. Okay, and improve on the existing one to make the model less dependent on the quantity and quality of data. Which means we have to create, okay, we need to do some research into AI fundamentals to create a robust approach which is less dependent on data, so that we can have a very good quality of knowledge discovery by using the data that we have, and to help our world to move into a better future. All right, sorry, I'm so sorry for the lengthy talk, and I hope the time is still sufficient, and that's all for my sharing. Thank you very much.
Okay, thank you very much, Dr. Rilampong, for your great lecture and valuable sharing. There are a lot of new and valuable information we achieved today.
Yeah, perhaps it's too much. All right.
Okay, maybe any other you wanted to deliver?
I think that's all I would like to share with the audience today. So perhaps now we can proceed to the Q&A, because I think the time is running out. We have about 10 more minutes for the Q&A, right? Okay. So perhaps not only questions, comments and ideas are welcome as well.
Okay, thank you. Participant may deliver the question via chat, or you can deliver question directly. Please raise hand before. And we have some questions. The first question is from Mrs. Resmi. Yeah. For us, with a background in the computer science, what kind of knowledge must we have to do some research related to smart agriculture? Should we collaborate to other fields of study, or our background knowledge in computer science is enough for starting the research?
Okay, for computer science, definitely, as I mentioned just now, computer science, especially in machine learning and data mining, it is the core of all the IR 4.0 technology. So even though we talk about robotics, computer science is still the core. Okay, without computer science, all these can only do their very basic level. All these technology can only do their very basic level. So what we can do now, what I would like to conclude now here is that this is the right time for us in the area of computer science to really do something to help the industry and also the world to make the process and everything better. So IR 4.0 has opened up a platform for computer scientists to really contribute into the applications of the world. So machine learning, data mining, natural language processing, even networking, a lot. As long as you can name it, we play a role in all these research and application areas.
Okay, thank you very much for your explanation. The second question is it possible to implement smart agriculture in rural area? Because most farming sites in Indonesia are in rural area where network is limited and electricity are not stable.
Okay, that will need some collaborations from the engineering side. For example, if let's say electricity is an issue, right? Therefore, we need to use renewable energy, for example, solar powered or wind powered and all these things, right? So we may not necessarily need the infrastructure from the municipal. Okay, we can create our own power source from the natural resources. Okay, electricity from natural resources. For example, we can use solar panel. Okay, this is the most commonly used. Okay, and nowadays with the advancement in computing technology, our processor and our computers, right, the power consumption of them has become lower and lower. Okay, just imagine nowadays we can power our smartphone by using just a small piece of battery. Okay, so 10 years back, we do not have such luxury. We cannot have that type of like for example, if you want to power a computer, okay, we need a very big battery back in 1980s. Okay, but now we can power a smartphone using a very small battery. So in rural areas, to source for the power is something that can be overcome by using renewable energy technology. Okay, and then when come to internet connectivity issue, of course, if we cannot get our system connected to the internet, we can always have edge computing. That means we have our processor and server on site. Okay, nowadays a very small processor, a very small server offer us a very powerful computational capability. So that is what we can consider. And of course, if let's say we can have the support from the government to build reasonable infrastructure into the rural area, and that will be good, of course.
Okay, thank you. The answer is very clear. So we turn to the next question. The next question is from Mr. Edi Suharto, and the question is, pertaining to smart sensors tagged to particular devices, how is about to handle fault tolerance? Example, corrupted data due to transmission or other network issues.
Sorry, your voice is breaking just now. Perhaps is the problem of my side. Can you please repeat the question?
Okay, how is about to handle fault tolerance? Example, corrupted data due to transmission or other network issue.
Okay, to handle corrupted data, right? Okay, we can always use the same technology, which is machine learning and pattern recognition, to predict the right patterns. Okay, of course, when we talk about corrupted data, we are not. Hopefully, we are not to have the corruption happen in the whole series of data. Maybe just some parts of it, and then based on the rest of the components of the rest of the data which are in good condition, we can always predict, okay, the appropriate value for the corrupted part. So if that is the case, techniques like machine learning and signal processing can come into the picture to handle that.
Okay. Okay, the next question is still related to data. The generation of data is increasing continuously, but how about noise? How we could recognize and remove noise from the data?
You're talking about noise reduction, right?
Yes. Yes.
Okay. Noise reduction, of course, in data mining, we have some, and data mining and signal processing, we have some techniques to handle that. Okay. We have, for example, we have principal component analysis. We have some other statistical model to reduce the noise. So we can always use the relevant data mining techniques to overcome the problem of how to say that, to overcome the problem of unclean, okay, the noisy data, okay, to make it, to process the data using statistical model, and also, like, for example, principal component analysis, to make it better for our classification and prediction.
Okay, thank you. We have next question. Okay, your sharing about implementation of smart agriculture is very nice, very interesting. But we see that in this smart agriculture, we use many devices. How to protect the device? Because the devices are usually located in the open environment. Is it a problem?
Okay, based on our experience working with the engineering team, I will say that the current devices, they are very robust to the harsh environment. Okay, even so, we have some very sensitive equipment of devices, right? We can always prepare a shield for it. For example, we have a proper casing to protect the sensitive device from harsh environment. But in overall, so far, the sensors and actuators that we need, that we are currently used for our project, right? They are very robust. Okay, they are very robust. They very strong. So it will not be a big issue for to say that the sensors or the equipment will be degraded or will be damaged by the harsh conditions of the farming at the farm.
Okay. Okay, thank you for your explanation. And we have also a question. Okay, And about the evaluation of the system, how we evaluate the model to ensure that the model or system works well in the real environment, yeah, because most of them are critical system, I think, because it is implemented in the real environment, such as in manufacturing or in agriculture.
Okay. At this stage, how we can evaluate the reliability or the performance of the model that we have developed, right? They are solely based on the benchmark data set that we can get online. Okay, because at our real implementation, as I mentioned, we are still at a very primitive stage, so we do not have much data to test and evaluate our system. And what we can do is we downloaded some data, some benchmark data from the internet, and then we try on them, we fine tune the model, and then until a level that we think that is satisfiable, then we deploy it, and hopefully in the future when we have collected enough data from the field trial, then we can do a more reliable testing which reflect the real environment. So now what we can do is just we predict the performance by using benchmark data set, okay, that we can acquire from the internet.
Okay, so the key point is data, yes.
Yes, the key point is always data. As I mentioned, again, as you can see from the second point in my conclusion, hopefully we can work out a robust model which will have less dependent on the quality of data and also the quantity of data. So that will really help in this type of application.
Okay, thank you for your explanation. Maybe any other question from participant? Maybe we have time for one or two questions again. Okay, there's a question typed in the chat panel, Dr. Lilam Hong, from Bernardinus Hendra. Thank you for your sharing session, Professor. From what I understand, the sensors are the main contributor to the success of the system. But I believe all sensors are also prone to failure, also depends on the quality, I guess. Is there any method or measure to detect, predict, or prevent sensor failure before it happens or before the bad data or reading from the failing sensor influences the whole system operation? Thank you.
Okay, so as I mentioned just now, sometimes we can due to some noises in transmitting the data or even failure of sensors, we do have noises. So how to design a robust sensor? Actually, I have minimal idea of that, so I leave it to our engineering team. But what we can do here is we use noise reduction techniques, some statistical model to predict the appropriate patterns from the whole stretch of time series data, and then from there, if let's say somehow we lost some parts of the data, what we can do is try our best to recover it or try to predict it so that we have sufficient data for our processing. So when come to the concern of the reliability of sensor, so based on our experience, to be honest, nowadays the sensors, they are very robust. The quality is very high. So I don't think that will bring any big issue to our applications actually. And because of most of our environment is quite controlled. Okay, if the farmers, of course, the conventional way they do farming, right, is quite uncontrolled, I would say. So if they want to implement the IR4 technology to do smart farming, right, so everything will be under control because we are going to use less manual machinery, so everything is automated, and perhaps everything is automated. We use automated robotic, everything, right? So that will protect our sensors from being spoiled or destroyed. So that is what we can do.
Okay. Okay, thank you very much, Dr. Lamhong, for your explanation. Actually, we would like to have deep discussion more, but because lack of time, we should end this session. So once again, thank you very much to Dr. Lamhong for your great and valuable lecture. Also, thanks to all participants in this room for your attention and participation in this visiting professor event. We hope that all we have learned and discussed today will give benefit to us. Okay, on the behalf of moderator in this session, I apologize if there is any mistake in guiding the session. Once again, thank you very much, Dr. Lilampong, for joining
Yeah.
this one. See you again in the next opportunity. Okay.
Yeah, thank you very much. Thanks for your time to hear my sharing here.
Yes,
All right.
really valuable sharing. Okay.
Okay.
So I return to Fauzan and Natasha.
Okay, thank you very much, Associative Professor Dr. Lee Lam Hong, for the amazing lecture. And thank you to Mrs. Hadijah MCS for moderating the lecture. Before we continue, we will have a virtual photo session together. So all guests and participants, we would like to ask you to turn on the camera. Okay, I'm gonna lead the photo session. I'm gonna count 1, 2, 3. So 1, 2, 3. And okay, that's all. Thank you for the participation. The photo session is finished. Once again, we would like to thank Associative Professor Dr. Lee Lam Hong for the amazing lecture. Hopefully, we can meet again in another visiting professor program.
Okay, now we're continuing to the next agenda, that is the closing statement from our acting head of departments, Dr. Eng Adi Wibowo. To Mr. Adi, the stage is all yours.
Mr. Ardi, you're still mute.
Okay, Assalamualaikum warahmatullahi wabarakatuh. First of all, dear special guest, Associate Professor Lee Lam Hong, thank you so much for your presentation and very valuable information for your research, and also all participants, moderator and MC. Thank you so much for joining this visiting professor. I hope this event very valuable for us for future, for our research, and we can continue to conduct the research in agriculture. I think it's very interesting. And for the last, I think thank you so much for everyone who support this event. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much for Dr. Eng Adi Wibowo for the warm close statements. Now we have come to the end of today's event. On behalf of the Department of Informatics, we would like to extend our gratitude to everyone who has attended this meeting, especially to Mrs. Dery Tantiwijaya and Associate Professor Dr. Lee Lam Hong, who has given us an amazing and interesting lecture. We hope to see you again in another visiting professor program.
So before we part, please accept our deepest apologies if there were shortcomings while we host this event. Thank you very much, and until we meet again, we wish you all a great day. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.